So let's look at another example of a linear function and see if see if you can prove, um, see if you could write a formal proof of when a limit exists for a linear function. So in a prior example, realize an answer here does require what I call what appears to be your think work. Some of you might call it as your scratch work. So make sure you have an aside column. You actually do the aside column first, and then do the formal proof second. All right. So you can't bypass the first procedure here. The first procedure is just as important as if not more, I should say. The first procedure is just as important, if not more, than your second procedure of a formal proof. So make sure you divide your first procedure and your second procedure with a vertical line. That way you can see where you write your proof. Your proof is actually over here. Here's your second procedure. And this is really the final answer. Your final answer will consist of 4 sentences when your function is actually linear. Go ahead and try this on your own. Try it for this particular example. Start with the first procedure off to the side here. And then remember your second procedure, it goes over here. And you'll write 4 sentences after you label the word proof. In the end, you end up circling, or at least encapsulating everything. So your first procedure is very important. People will require that. People will require what you were thinking and how you were able to come up with that delta. So this procedure is important. And then your second procedure is here, which is all 4 sentences, and that will actually conclude your formal proof. We could end a formal proof with some dramatic symbol here called a tombstone. So if you were wondering what this was actually called a tombstone here that marks the end of a proof. You'll see that in textbooks as well. You see a little box from time to time. Sometimes it's shaded in, sometimes it's not. But that will usually mark the end of a proof in a calculus textbook. Here's a linear function that requires a little bit more algebra. I wouldn't say a whole lot more algebra, but you just have to be very careful. Once again, give this a try. If you need to, pause the video, okay? Pause the video and actually attempt this yourself, all right? But I will go ahead and silently write a solution here. So when you're ready to check your answer, go ahead and replay the video and see what you get.